Hello everyone and welcome back to our channel. In today's video, we're going to do the average function in PySpark, a fundamental tool for calculating averages in your datasets. Whether you're dealing with sales data, financial metrics, or any other numeric information, calculating the average is a key step in understanding the overall trends and patterns. We will cover how to use the average function to compute the mean for both entire datasets and specific groups, making it simple to get valuable insights. So let's jump in and explore how to make the most of this powerful function. Introduction to the average function. The average function in PySpark is used to calculate the average or mean value of numeric columns. It functions similarly to the average function in SQL, offering a straightforward way to determine the central tendency of a numeric dataset. By calculating the mean value, average helps you quickly understand the overall distribution of your data, providing insights into its general characteristics. The average function can be used directly beyond a column to calculate the average across the entire data frame, giving you a single value that represents the mean of all entries in that column. This is especially useful when you need a high-level overview of a metric such as determining the average sales revenue or performance metrics. Additionally, average is often used in combination with group by to calculate the average value within specific groups. For example, you can group by category like region, product, or department, and then use average to calculate the average sales or profit for each group. This type of grouped average is valuable for making comparisons between different segments of your data, helping to identify trends, anomalies, or high performing groups. Whether calculating a global average across the entire dataset or grouped averages for specific categories, the average function is a fundamental part of data analysis in PySpark. It provides an efficient way to derive key metrics that summarize data, helping data analysts and engineers better understand the patterns and trends within their datasets. By leveraging the average function, you can drive actionable insights that inform decision making and reveal the overall performance of your data. Basic syntax. The basic syntax for using the average function in PySpark is DataFrame.group by cols.aggregate average column num. This syntax allows you to calculate the average value of a numeric column within your data frame, either for the entire dataset or for specific groups. The group by part of the syntax specifies one or more columns by which you want to group the data, allowing you to segment your dataset into meaningful categories before performing the aggregation. The cols parameter in group by specifies the columns that define each group. For instance, if you want to calculate the average sales for each product category, you would use group by to group the data by the category column. Grouping data allows you to calculate averages for each segment individually, making it easier to compare performance or identify trends within those specific segments. After grouping the data, you use the add function to apply an aggregation operation to each group. The average column name part specifies that you want to calculate the average of a particular column for each group. For example, if you are grouping by a column like region, you could use average sales underscore amount to calculate the average sales amount for each region. The result is a data frame that contains each group along with its corresponding average value for the specified column. Using average with group by is especially useful for analyzing data distribution and identifying patterns within different segments of your dataset. It allows you to determine how values vary across different categories, such as finding the average revenue per region or understanding the average performance of different products. This makes it easier to gain insights into your data, enabling better comparisons and data-driven decision making. Whether you are calculating averages across the entire dataset or for specific groups, the combination of group by and average is a powerful way to summarize numeric data in PySpark, allowing you to quickly derive meaningful metrics that help in understanding your data and making informed decisions. Why use average? The average function is a widely used aggregation operation in data analysis because it provides a clear and concise way to determine mean value of a data. Calculating the average is an essential part of understanding your data, especially in fields like financial analysis, data profiling, and summary reporting. The average function helps you quickly assess the central tendency of numeric data, providing a single value that represents the typical or expected value within dataset. This makes it easier to understand the overall characteristics of your data, such as the average sales revenue, average customer expenditure, or average product. The average function is particularly effective when trying to understand central tendencies in numeric data. By calculating the average, you can gain insight into the general behavior of your dataset and identify what is typical. This is important when working with large volumes of data as it helps to summarize and condense information into a meaningful value that is easy to interpret. For example, calculating the average income of customers can help a business better understand its customer base, while finding the average test score can help educators evaluate the general performance of students. Furthermore, average works exceptionally well in combination with group by to compare different groups within your data set. By grouping your data into categories such as product types, regions, or customer segments, you can apply the average function to determine the mean value for each group. This is useful when you want to compare the performance of different categories, identify trends, or understand how different factors contribute to the overall dataset. For instance, finding the average sales for each product category can help determine which products perform the best, while calculating the average revenue for each region can highlight which areas are generating the most income. Overall, the average function is fundamental for summarizing data, understanding central tendencies, and making comparisons between groups. Whether you need general overview of your data set or insights into specific segments, using average helps you derive meaningful metrics that support informed decision making and effective data analysis. Practical examples. No. 1. Calculating the average of a single column. In this example, we are working with a PySpark data frame div that contains sales data for different items. Data frame has two columns, item and sales, where item represents the name of each product and sales represents the sales value for that item. The dataset includes multiple records for different items, with some items appearing more than once, representing separate sales transactions. The goal here is to calculate the average sales value across all transactions recorded in the data frame. To achieve this, we use the ag function along with the average function. Specifically, average sales calculates the mean value of all sales entries in the sales column, providing a summary metric that represents the central tendency of the sales data. After calculating the average, we use alias average underscore sales to rename the resulting column as average key underscore sales. This makes the output more informative, clearly indicating that the value represents the average of the sales values across all transactions. This kind of average calculation helps provide a high-level overview of the dataset, summarizing the overall sales performance in a single, easy to understand value. Finally, we use the .show method to display the result. The output will contain a single row with one column named average underscore sales, which shows the average sales value for all items in the dataset. For example, if the sales values are 100, 200, 300, 400, and 500, the average function will calculate the mean as 300. This provides insight into the typical sales value, helping us understand the general behavior of the dataset. This example demonstrates how you can use ag along with average to calculate the mean value of a column for the entire data frame. Computing the average sales is an important step in data analysis as it helps you understand the central tendency of your data, providing a summary metric that represents the overall level of sales performance. Whether working with financial data, sales records, or other numeric datasets, the average function is an essential tool for deriving meaningful insights and informing decision making. 2. Grouping and calculating averages. In this example, we are working with a PySpark data frame DF that contains sales data for different items. The data frame has two columns, item and sales, where item represents the name of each product and sales represents the sales value associated with that item. Since multiple sales transactions are recorded for some items, the data contains repeated entries for items like item I and item, each with different sales values. The goal here is to calculate the average sales value for each individual item. To do this, we first use the group by function to group the data by the item column. This step aggregates all the rows with the same item value into a single group, allowing us to perform calculations for each item separately. Essentially, all sales transactions related to item are grouped together, as are those for item and item C. After grouping the data item, we use the add function along with average sales to calculate the average sales for each group. The average function calculates the mean value of the sales column within each group, giving us the average sales for each item. This helps to understand how each item is performing in terms of its typical sales value across different transactions. To make the output more readable, we use alias average underscore sales to rename the resulting column as average underscore sales. This clearly indicates that the values in this column represent the average sales for each item. Finally, we use the .show method to display the resulting data frame, which contains two columns, item and average underscore sales. The item column lists each unique product in the dataset, while average and while underscore sales shows the average of all sales values recorded for that item. For example, if item A has sales values of 100 and 300, the average function will calculate the mean sales as 200 for item A. Similarly, item B might have sales values of 200 and 500, resulting in an average of 350. This grouped average provides valuable insight into how different items perform over time, allowing for comparisons between products and helping identify which items consistently achieve high average sales. This example demonstrates how to use group by and average together to calculate averages for different groups within a dataset. Group aggregation like this is particularly useful in data analysis as it helps you break down the data into meaningful segments and understand the behavior of individual groups. By calculating the average sales for each item, you can gain a clear understanding of which products are performing well, how consistent the sales are, and where there might be opportunities for growth or improvement. 3. Calculating averages for multiple columns. In this example, we are working with a PySpark data from beef underscore multi that contains sales and profit data for different items. Data frame has three columns, item, sales, and profit. The item column represents the name of each product, the sales column contains the sales value, and the profit column represents the profit earned for each sales transaction. The dataset includes multiple transactions for some items such as item A and item B, each having different sales and profit values. The goal here is to calculate the average values for both the sales and profit columns across the entire dataset. To achieve this, we use the aggregate function in combination with the average function. Specifically, average yields calculates the mean sales value across all transactions, while average profit calculates the mean profit value across all records. These averages provide important summary metrics that help to understand the central tendencies of both the sales and profit for the entire dataset. By using alias, we rename the calculated average columns to average underscore sales and average underscore profit for better readability and interpretation. This makes it clear that the resulting values represent the average sales and average sales and average profit, respectively, for all the items in the data. Using descriptive column names helps to communicate the meaning of the output clearly. The dot show method is then used to display the result, which consists of a single row with two columns, average underscore sales and average underscore profit. The average underscore sales column contains the average of all the sales values, while the average underscore profit column contains the average of all the profit values. For instance, if the sales values are 100, 200, 300, 400, and 500, the average function will calculate an average sales value of 300. Similarly, for profit values of 10, 20, 30, 40, and 50, the average profit will be 30. This example illustrates how you can use the aggregate function along with average to calculate multiple averages simultaneously across different columns in a data frame. Calculating averages for both sales and profit provides insight into the overall performance of the dataset, helping to understand the typical revenue and profit margins associated with the recorded transactions. This type of summary metric is useful for high level analysis, allowing you to quickly assess how well the business is doing in terms of both sales and profitability across all items. 4. Grouping and calculating multiple averages. In this example, we are working with a PySpark data frame diff underscore multi that contains sales and profit data for various items. The data frame has three columns: item, sales, and profit. The item column represents the name of each product. The sales column contains the sales values for those items, and the profit column represents the profit associated with each sales transaction. Since multiple transactions are recorded for some items, such as item A and item B, we need to understand the average performance of each item across different transactions. The goal here is to calculate the average sales and average profit for each individual item in the dataset. To accomplish this, we first use the group by function to group the data based on the item column. By using group by, we group all the transactions related to the same product together, which allows us to perform aggregate calculations for each item separately. After grouping the data by item, we use the add function to apply multiple aggregation operations. Specifically, we use average sales to calculate the mean sales value for each item and average profit to calculate the mean profit value for each item. These averages provide insights into the typical performance of each product in terms of both sales and profitability. By using alias average underscore sales and alias average underscore profit, we rename the resulting columns to make it clear that they represent the average sales and average profit for each item. Finally, we use the dot show method to display the resulting data frame. The output contains three columns: item, average underscore sales, and average underscore profit. The item column lists each unique product in the dataset, while average underscore sales and average underscore profit show the calculated averages for the sales and profit columns respectively for each item. For example, if item A has sales values of 100 and 300 and profit values of 10 and 30, the average sales for item A will be 200 and the average profit will be 20. This example demonstrates how to use group by in combination with HAG and average to calculate multiple average metrics for different groups within dataset. Group aggregation like this is particularly useful when analyzing the performance of individual items, as it allows you to understand both the average revenue and average profit associated with each product. This helps to identify which products are performing well consistently and which products might require further attention to improve profitability or sales performance. 5. Using average with a conditional expression. In this example, we are working with a PySpark data frame diff that contains sales data for various items. The data frame has two columns, item and sales, where item represents the name of each product and sales represents the corresponding sales value for that product. We want to calculate the average sales value, but only for transactions where the sales value exceeds 200. To achieve this, we use a combination of the when function and the average function. The when function is used to create a conditional expression that selects only those sales values that meet a specific condition. In this case, when def dot sales 200 df dot sales checks if the value in the sales column is greater than 200. If the condition is true, it returns the value of sales, otherwise it returns null. This ensures that only the sales values greater than 200 are considered for further calculation, while all other sales values are ignored. Next, we use average to calculate the average of the sales values that satisfy the condition. Specifically, average when def.sales 200 df.sales comp is the average of only those sales values that are greater than 200. This allows us to get the mean sales value for higher value transactions, providing insight into how larger transactions are distributed within the dataset. We use alias average underscore sales underscore over underscore 200 to rename the resulting column to average underscore sales underscore over underscore 200. This makes the output more meaningful and easy to interpret, as it clearly indicates that the value represents the averages for transactions where the sales are greater than 200. Finally, we use the dot show method to display the result. The output will contain a single row with one column named average underscore sales underscore over underscore 200, which shows the average of all sales values that exceed 200. For example, if the sales values are 100, 200, 300, 400, and 500, the average be calculated using only the values 300, 400, and 500, resulting in an average sales value of 400. This example demonstrates how you can use conditional logic with the when function in combination with average to perform selective aggregation. By calculating the average of sales values greater than a certain threshold, you can gain deeper insights into your data, particularly focusing on high value transactions. This approach is especially useful for data analysis scenarios where you need to isolate specific segments of data, such as understanding the performance of high value sales, evaluating profitable customers, or identifying trends among larger transactions. 6. Calculating a global average. In this example, we are working with a PySpark DataFrame div that contains sales data for different items. The data frame has two columns, item and sales, where item represents the name of each product and sales represents the corresponding sales value for that product. Our goal here is to calculate the average sales value for the entire dataset, considering all transactions regardless of the item. To achieve this, we use the add function in combination with the average function. The average sales operation calculates the mean value of all the sales recorded in the sales column. This global average provides a summary metric that represents the central tendency of the sales data across all items. It is helpful when we want to understand the overall performance of sales in the dataset without breaking it down into individual groups. By using alias global underscore average underscore sales, we rename the resulting column to global underscore average underscore sales to make the output clearer and more informative. This makes it easy to identify that the value represents the average sales across the entire data frame. Finally, we use the dot show method to display the result, which consists of a single row with one column named global underscore average underscore sales. The output will provide a single value that shows the average of all the sales recorded in the dataset. For example, if the sales values are 100, 200, 300, 400, and 500, the average function will calculate the mean as 300. This global average value gives us a high-level overview of the dataset, allowing us to understand the typical sales amount across all items and transactions. This example demonstrates how to use aggregate along with average to calculate a global average across an entire data frame. Calculating the average of the sales column provides a quick summary of how sales are distributed, helping to understand the general behavior of the dataset. This is particularly useful in scenarios where you need to assess the overall performance or gain an initial understanding of the dataset's characteristics before diving deeper into segmented analysis. Thank you for watching. I hope you found this video helpful in understanding how to use the average function in PySpark to calculate averages and gain meaningful insights into your data. Whether you need a global overview or want to compare different categories, the average function is your go-to tool for determining central tendencies. If you enjoyed this video, please like, share and subscribe to our channel for more tutorials on PySpark and data analysis. If you have any questions or suggestions for future content, feel free to leave a comment below. Until next time, keep learning, keep coding and happy analyzing.